You can load data into your data model by explicitly writing the query in SQL language. In this data model, we already loaded from a SQL Server database 4 tables: the fact internet sales, the DIM product category, and the DIM product subcategory. Now, instead of having 3 different tables that we have to join into the data model, we want to import a single denormalized product table that contains all the attributes from the product category, and product subcategory tables. For this reason, we are going to create a SQL query to do the job. Since we already defined a connection to the database, we will use an existing connection in order to create our query. So now we click on existing connections, we select the connection we already opened before, and after clicking open, we select write a query that will specify the data to import. At this point, we have to write the SQL statement. Now, if you are a very good SQL programmer and you remember by memory all the name of the tables and the columns, you can continue writing the SQL statement in this text box. Otherwise, by clicking on Design, we have a dialog box that will help us writing our SQL query. In the left pane, named Database View, you have a list of all the objects that you have in this database. For each schema, you have a list of tables, views, and store procedures. By opening the Tables node, we can see a list of all the tables in this database. From these tables, we select the DIM product category, and the DIM product subcategory tables. In this way, we selected all the columns from the selected tables, and we auto-detected the relationships between these tables. The query that has been generated for us is visible as soon as you click OK on this dialog box. This query is written in SQL language and contains the list of all the columns and a few statements in SQL like from and join that we will see better in a few moments. As soon as we click the Finish button in this dialog box, the query that we wrote is sent to the SQL Server database, and the result of this query is returned to the Power Pivot data model. Now, remember that we imported 397 rows from this query, and now let's take a look at the other table, the DIM product table, which contains a different number of products, because we have 606 rows here. So it is strange that the query that we created imported a lower number of rows, a lower number of products. In order to understand what is going on, we can open the table properties and edit the query in the designer again. Here you can see that the relationships pane has the auto-detect selected. And here you see that we have 2 relationships between the 3 tables that we imported. And this relationship has a join type that is inner. This is the reason why we missed some products in the result of the query. In order to understand why this is happening, let's take a look at a few concepts of the SQL query language. The syntax of a query in SQL has a few keywords that are used by this language. For example, you have select, from. After the select you have a list of columns, and after the from you have the table from which you want to get the data from. Now, in case you have more than one table in your data model and there are relationships between the tables that you want to import, you will obtain a single table as a result, and it is important that you specify the join between these tables in a correct way. For example, the syntax that you see in this slide has an inner join between 2 tables, product and product subcategory, and the on condition specifies which columns on the 2 tables have to be considered part of the relationship. When this query is executed, you obtain only the rows from the product table that also have a corresponding row in the product subcategory table, having the product subcategory ID in one table equal to the value in the other table. So all the rows that satisfy this condition will be part of the result. So this is the reason why we obtained a lower number of products. All the products that don't have a corresponding subcategory have been excluded from the result of the query that we created before. just because we used the inner join that excludes all the products that do not have a corresponding subcategory. And in our database, we have a few products that do not have a corresponding subcategory, because the product subcategory ID is null for a few products. However, we have different kinds of relationships. Instead of using the inner join, we can use the left, the right, or the full outer join, which are different kinds of relationship that do not filter all the rows. In particular, the left outer join says that the left table is preserved, so the table that is on the left of the join will keep all the rows, and only the corresponding rows from the table on the right will be included in the result. If the relationship is missing, the value for the columns on the right table will be null. Right outer join works in the same way but in the opposite direction, so the right table is preserved and the left table has null values if there is no corresponding row on the left side for the key that you use in the relationship. In the full outer join, both tables are preserved. With this knowledge in mind, we can change the join type of our query in order to keep the products that do not have a corresponding subcategory. We cannot change which table is on the left side and on the right side of the join, because this wizard automatically chooses which position each table has. As you see, the dim product subcategory is always the left table. Now, in the first row of the relationships, we have the relationship between the subcategory and the product, and we know that we want to keep all the products. So we need to keep all the rows from the right table, so we change the join type to our right join. It is common to always use the left join in many cases, but as I said, since we cannot change the position of the tables, we have to adapt the join type to the position of the table that has been decided by the wizard. The second relationship is between the subcategory and the product category, and in this case we might have a subcategory that don't have any corresponding category. In this case, we want to keep all the subcategories even if there are no corresponding categories. So we change the join type to a left join or left outer join, and in this way we preserve all the subcategories. After having fixed the join in our query, we can click OK and then Save in order to execute the query on the database. The result this time will be 606 rows in our query, which is exactly the same number of rows in the dim product table. We finally have all the products in our query, and as you can see, if you look at the columns that comes from the subcategory and category tables, we have a blank value for all the products that don't have a corresponding subcategory, whereas we have values from these other tables when the join is correctly resolved.